This is a game called Aimbot. It's a game designed to help you with your aiming. There are several game modes that are all just different versions of shooting this orb. Now, Aimbot has 100 different achievements that you can get if you play these game modes a varying amount of times. Theoretically, could you write a script that just plays the game mode over and over and over again until you get the achievement? Yes. And that's exactly what I did. But after the computer kept playing the same game mode over and over and over again, it just sat there, staring at the same blue ball, destined to be stuck in this loop forever. Or was it? So, hold on. So what needs to happen is I need to take a screenshot, and then I need to analyze that screenshot. So let's first work on making a screenshot. Oh, there it goes. I don't know why that worked. Hey! All right, now the next step is to look for, we gotta look for blue, right? So, all right, so the computer is looking for this set of specific pixels. Now, there's a couple different ways you can do this. Python has a very helpful built-in library called Python Automatic Graphical User Interface, or PyAutoGUI for short. This library has a function that just lets you search for an image on the screen. If it finds the image on your screen, it returns an X and Y value. Now, I was reading on the PyAutoGUI documentation website that it can take a while for this function to execute. Takes about 1 or 2 seconds. That is pretty dang slow. The other option is to analyze each and every pixel on your screen individually until you find the color blue. I think we're gonna go the analyze every single pixel route. What I didn't anticipate is how long it would take. Is this still running? Is it really taking this long? That's because on a regular 1920 by 1080 monitor, there are over 2 million pixels? Hold on, I feel like we just take this stuff for granted, you know what I mean? That means if the computer analyzed 1 pixel every 1/10 of a second, it would take 57 hours. So in an attempt to save some time, I had an idea. We're gonna make it count by intervals of 5 instead of 1, or maybe even 10, honestly. The blue orb that the computer is trying to search for is at least 50 pixels by 50 pixels. So my thought process was maybe the computer could find it by analyzing 1 out of every 10 pixels. Is it working? No. It's not. Honestly, though, maybe I could do 100. You think? I bet you 100 would work. It did not work. New plan. So new plan. Taking a screenshot of anything in that center gap. So it turns out PyAutoGUI has a parameter that lets you take a screenshot of only a specific section of your screen. This speeds up the process of finding whatever you want to find exponentially. Okay, found it. Phenomenal. And it gave me the coordinates. So now that we have the coordinates for the orb, we have to tell the mouse to move towards the orb. Theoretically, you should be able to tell the computer to just move the mouse cursor to those coordinates. That doesn't work though. Just trust me. I spent way too long trying to figure that out. Okay, I don't think absolute movement works in this game, unfortunately. So instead what we have to do is we have to take the coordinates of the orb and subtract the coordinates from the center of the screen. This will tell the computer by how much the mouse needs to move in the X and Y position. Now I run into a different problem. See, I'm playing a game mode called Microshot. In Microshot, you have to hit targets of all different sizes. PyAutoGUI is really only good at looking at targets of one size. So to fix this problem, I switched over to a new game mode called Gridshot. It's kind of working. Okay, wow. I'm moving the mouse a little bit. It's a 10% confidence level. Let's see what that does. All right, hands off. No, too little confidence level. You know what I think I need to do is increase the region that I'm taking the screenshot. Okay, what are you shooting at? There's nothing blue there. Okay, we're getting somewhere. Hey, there we go. That's what I'm talking about. Okay. So as you can probably tell, it's not 100% accurate. In an attempt to raise the accuracy, I added a check to only fire when the pixel in the center of the screen is equal to blue. It's making a lot of micro adjustments. I want it to make one big adjustment. You know what I mean? I'm figuring out where the center of the screen is, and then I'm figuring out where the blue ball is, and I'm just figuring out how many pixels it takes to get there. That's how the mouse is moving. But the sensitivity of the mouse will affect how accurate that is. And my sensitivity is at 0.75. So I think if I just move that to 1, that'll make a drastic difference. But I have no idea. We're just going to see if that works. Okay, it's better. What if we like crank this up to 11? No, let's be reasonable and do 5. Whoa, that is sensitive. Yeah, that's not working. That's not working very well. I think I just have to tweak this and find the perfect sensitivity for the program that I made. Okay, we're getting closer. Oh, actually, wow, this is working. Only 20% of what I can do. It's a little slow. It's a lot slower than I'd like it to be. And I don't know how to speed it up. You don't like AimLab cheater? Okay, well, I'm not. Listen, okay, I'm not doing this in like a nefarious way. I just want to see if I can do it. You know what I mean? Okay, so I've noticed that when it's in the bottom right, it struggles because the gun's in the way. You can remove the gun. Invisibility. Hide. Oh my goodness. Oh my goodness. Okay. Okay. Working much better now. Okay, but it's not 100% accurate, which is what we're trying to accomplish. So after a lot of tweaking and experimenting, this is what I discovered. I had to set the mouse sensitivity to 1.2. The X and Y value that the computer calculated to move the mouse, I also had to multiply by 1.2. After that, it was just a matter of finding out how fast the computer could go. Okay, that's too slow, but it's working. It's working very well. Oh. Okay, I've run into a problem. They're all 3 up there, and the search area is not big enough. And now I present to you the finished product.
Pick it up, pick it up, pick it up, pick it up. You see the drippy, I fit it up. Hop in my car and the giddy up. Secure the bag, yeah, I get the bus. Pick it up, pick it up, pick it up. You see the drippy, I'm fitted up. Hop in my car and the giddy up. Secure the bag, yeah, I get the.
But wait, that's not all. Naturally, I wanted to take my aimbot onto the ranked servers, but I ran into a problem. All right, let's see how we do. Oh. The balls shrank. So I modified my code to say, hey, if you can't find this ball, look for the same ball, just slightly smaller, and keep doing that until you find a ball to shoot. Ultimately, I got a pretty good score. I ranked number 11, but at the end of the day, I couldn't get first place. This guy's insane. Look at this. Now you may be saying, oh, he's just using an aimbot. He's not using an aimbot. And you can tell because the lines aren't perfectly straight from when he shoots one target for when he shoots another target. See, like this is my personal best. I think I'm rank 13. Look at the lines in between shots. Perfectly straight. Listen, I'll be the first one to admit that I know when I'm defeated. However, this project was a lot of fun and my goal was never to be the top one on the leaderboard. Ultimately, that is the end of the video. I've never done anything like this before. This is kind of a new form of content for me, so if you enjoyed this, make sure you subscribe. That lets me know that you enjoyed it. Also, I streamed all of this on Twitch, so if you want to go follow me on Twitch, the link is in the description. And I will be back next week with another video.